This is the basic design of our cladogram or phylogeny that we're going to follow. You notice a few derived characters. Remember, you can pick those out by these red lines, okay? But these are the 9 major phyla that we're going to focus on in our discussions. And we'll actually start at the left and pretty much march our way through to the right side of our phylogeny here. And the reason we do that is because it's following the design of the cladogram. So we see over here these periphery or sponges all by themselves. Do you remember what we called that when we had a group all by itself out to the side? When we talked phylogenies, we called that an outgroup. And the reason the sponges are an outgroup on our tree is because they're the only organism or phyla here that we see that has no true tissues or organs and no symmetry. It's a mess. We'll look at it. Before we get into all of our discussions about particular phyla, we want to walk through a couple of those characteristics that we've mentioned briefly before. So when we look at symmetry, so I said that we could have radial or bilateral symmetry. We actually have a third choice to be asymmetric or no symmetry whatsoever. So this is our sponge. Falls into our asymmetric category. You see, there's no good way to slice this organism to give it any sides, right? But if we look at our bilateral symmetry, like in our dog here, you are also bilaterally symmetric. It means that if we split you down the middle, we have a mirror image on each side. Is it perfect? No. But we get pretty darn close because of our design with 2 arms, 2 legs, 2 ears, 2 eyes. Okay, you get the idea. Now, when we look at our jellyfish over here on the far left, we can look at this idea of what we call radial symmetry. I also refer to this as pi symmetry, meaning that I can cut this many different ways and I would still get half, half, half. These halves would be identical no matter how I cut this, right? So it's like cutting a pie. Think about the first cut in a pie when you cut it in half. It doesn't matter where you start, right? As long as you cut it in half, and then we cut it in half again usually and cut it into individual sections like they've started to do here with our jellyfish. But the idea is there's some central point to this organism around which we build the rest of the organism. When we look at symmetry on our tree here, we see that symmetry comes up as a derived character right about here, okay? That means that for our sponges, there's no symmetry. So we said it was asymmetric, right? So the symmetry for the rest of these, we have to think about. All right, well, if we look at these guys, we have our cnidarians, our jellyfish that we mentioned. We said that they were radial. Everything else we're going to look here actually falls into our bilateral symmetry. Okay, so you can see how we're starting to divide out our tree, right?